17 days after launch, one of the most ambitious Earth-observing satellites ever built has bloomed in space. Meet NISAR, a joint mission between NASA and India's space agency, ISRO. Its massive golden radar antenna has just unfurled, and with it, a brand new era of Earth science has officially begun. So what makes this satellite so special? How does this giant antenna actually work? And why does it matter to every single one of us on Earth? Let's break it down. On August 15, 2025, engineers at NASA's Jet Propulsion Laboratory and ISRO celebrated a critical milestone: the unfurling of NISAR's massive antenna reflector. This reflector is 39 feet across, about the size of a school bus, making it the largest antenna ever deployed on a NASA Earth science mission. At launch, the reflector was neatly folded up like a compact umbrella. But once in orbit, a 30-foot boom extended, explosive bolts released, and in just 37 minutes, the reflector bloomed into its final circular shape. It's not just big, it's delicate, weighing only about 142 pounds and built from 123 lightweight composite struts covered in a fine gold-plated mesh. This combination makes it both strong and light enough to survive the violent launch and then function flawlessly in orbit. So what does this giant dish actually do? It works with NISAR's two synthetic aperture radars, an L-band radar from NASA and an S-band radar from ISRO. The L-band can see through clouds and even dense forest canopies, perfect for tracking ground deformation and ice movement. The S-band is more sensitive to lighter vegetation and moisture, making it ideal for monitoring crops and snow. Together, they bounce radar signals off Earth, collect the reflections, and turn them into detailed images. Thanks to SR processing, NISAR can achieve resolution down to 30 feet, sharp enough to detect tiny changes, like land shifting by just fractions of an inch after an earthquake. NISAR's mission is all about change, Earth's constantly shifting surface. It will scan almost all of Earth's land and ice twice every 12 days, building a time-lapse view of our planet like never before. Here's what it will track: glaciers and ice sheets melting in Greenland and Antarctica, helping scientists measure sea level rise; earthquakes and volcanoes by detecting minute ground shifts before and after events; landslides offering insights into risk zones for communities; forests and wetlands, critical for understanding how much carbon the planet is storing or releasing; and even farmland, from planting to harvest, providing farmers with better data to improve food security. As NASA's Karen St. Germain put it, the data NISAR gathers will directly help decision-makers prepare for disasters, improve infrastructure, and secure our food supply. To achieve this level of precision, a normal radar antenna would need to be 12 miles long. That's nearly the length of Manhattan. Clearly, that's impossible. Instead, NISAR uses the power of synthetic aperture radar, and the giant golden reflector makes it possible. Think of it like the lens of a camera. The bigger the lens, the sharper the picture. Without this reflector, the radar images would be blurry and not very useful. With it, they become sharp, detailed, and transformative. Building this reflector took years of design, testing, and international collaboration. It had to survive launch vibrations, fold neatly for storage, and then open flawlessly in space. The deployment relied on a system of explosive bolts, motors, and tension cables, each step carefully timed. One mistake, and the entire mission could have been crippled. That's why this deployment is being celebrated as one of the most critical moments of the mission. As project manager Phil Barella said, "Now that it's deployed, we can focus on fine-tuning and preparing for science operations by late fall of this year." NISAR is also a story of global cooperation. The US and India each contributed key technologies. NASA built the L-band radar, the reflector, and advanced communication systems. ISRO provided the spacecraft bus, the S-band radar, and the launch vehicle. Together, they've created one of the most sophisticated radar satellites in history. It's a testament to what's possible when nations collaborate, not just for exploration but for protecting our planet. So here we are, a golden antenna the size of a school bus now orbiting Earth, ready to revolutionize the way we study our planet. In the coming months, NISAR will begin sending back its first data, building 3D movies of Earth's surface and tracking changes that affect us all, from climate to agriculture to natural disasters. It's science in action. It's technology at its most inspiring. And it's proof that when we look to the stars, or in this case, back at Earth, collaboration and innovation can bloom into something extraordinary.